that's really what we're going to study all this week is more recursion. And if recursion was a little weird last lecture or didn't totally make sense, then that's OK. And at some point, a lot of people it just clicks. Something about it, after some amount of time, a certain example, or maybe writing some homework code with it, at some point you go, oh, and this light bulb kind of comes on, and you sort of get it. It just takes a while, and a different moment for different people will trigger that. And I remember having that moment. But I don't remember what I felt like just before that moment. You know what I mean? So I wish I could tell you exactly what got it to work for me. But I think the technique we've all settled on as teachers is to just do lots of examples and bombard you with code and examples and pictures and stuff, and just hopefully something will stick. Anyway, I'm just trying to emphasize that this is a tricky concept that we're going to continue to understand more as we go along. It takes a while. So with that in mind, we were writing some code last time, and I want to jump back into some of that code. We wrote a function to compute a base to an exponent called power. We wrote that one. And of course, we also learned about throwing values. You could throw an exception to the caller of the function to tell them they didn't pass a good value. So we did that. Remember that when we do recursion, we do these base cases that are the easy cases, and the recursive cases that are the hard cases. And the obvious thing that differentiates them is the base case does not make a recursive call. The base case doesn't call power, but the recursive case does. So that's how you differentiate those two. We also wrote an isPalindrome function that would tell us whether a string was the same forwards as backwards. And again, in all these problems, you want to ask yourself the same question. How is this problem similar to itself? How can you describe a solution to this problem in terms of a smaller version of the same problem? And what you guys told me last lecture was great. You said telling whether a string is a palindrome, if we just did a little bit of the work ourselves by checking the end characters, the start and the end character, then maybe we could use recursion to check whether the rest of it was a palindrome. And if the rest is a palindrome and the edges are the same, then the whole string must be a palindrome, right? So that's the relationship that we tried to capture in this code right here that we wrote. So I wanted to point something out. There's a couple things about this code that I want to do here. One is if I run this and I just look at the output on the console, you might see that there's a few small mistakes. Like this one says step on no pets returns false, but actually that string is the same forwards as backwards. That's just a tiny little thing where we need to go to the start of our code and say s is the to lower case of itself. OK, so we'll just compare case insensitively. So that's not really a recursion issue. There's another thing I wanted to point out. So right here, let's talk about this code. This is the recursive case. And this is where we've decided to compare the first and the last character. So if the first equals the last, then we chop out the middle of the string. If the first doesn't equal the last, we just exit with a false. I want to talk about this line of code that's highlighted, where it says return is palindrome middle. A lot of students, when they're writing recursive code like this, they just put is palindrome middle. And I mean, that's really close to being the right idea, because you're sort of saying, I want to do the recursion, and I want the string to now be the middle part and not the whole string. But do you understand why I need to say return is palindrome middle? Like, what does that do exactly? What does that mean when I say that? And what does it do if I don't say return? If I write it this new way, what does that do? What's the difference between those two?
In the method name, you're saying that you're going to return a Boolean, and so if you don't return anything, then if it is a palindrome, like it'll crash because it won't have returned anything.
Yeah, I like the way you said that. You said that in the heading of this function, it says I'm going to return a bool. I'm promising to do that right here. And therefore, I have to fulfill that promise. I have to return some Boolean value. And so a lot of these paths of code do return Boolean values. But this path right here, if you just say is palindrome middle, that's going to go off and do an exploration and come back and return something to me. And then I'm not going to do anything with that. I mean, whatever he returns, I want to return. That's the way I want to think of it. If the middle part, if that call returns a true, then I want to return a true. If the middle part returns false, then I want to return a false. And so, I mean, another way of writing this would be like bool temp equals that, return temp, I don't know if splitting that out helps people maybe understand, like, I have to make this subcall. It's going to return some result to me. Whatever that result was, that's my result. Because the end characters for me are the same. So all that matters is the middle. You know, if this thing, instead of race car, was Ragnar, which is some relay that you can run, like if you went on the Ragnar relay, well, the R's would match and the A's would match, but then at some point the G's and the N's wouldn't match. So that subcall of his palindrome would return a false. And so the other calls need to echo out that same false all the way back out. So one thing that I think is kind of tricky for some students is understanding recursion with returns, how you have to hand the results back and up forward and stuff like that. It's kind of similar to up here when we say power. We don't just say base times power. We say return base times power, right? Same kind of thing here. OK, so that's a power function. That's his palindrome function. I want to write one more. I want to talk about one called print binary. So this one, I don't have a slide for on the screen right now, but you pass it an int, and it will print the binary equivalent of that int. So you guys know binary ones and zeros, right? I mean, the far right digit is the ones, and then the next digit is the twos, and the fours, and the eights, and the 16s, and the 32s, right? So the number 43 has a 32, and an 8, and a 2, and a 1, I think, right? So how do you do that recursively, though, with no loops? Well, when we're writing recursive code, what's usually the structure of that code? What do we usually start thinking about in the bodies of these recursive functions? We usually split into two cases, right? This base case, I heard people saying base case, and then a recursive case. So if something, base case, and else, recursive case, right? OK. And then the base case are the ones that are easy. So like, printing things in binary sounds kind of hard, but I bet there are some numbers that are probably easy to print without doing a bunch of recursion or loops or anything like that. What's a number that would be really easy to print, or a range of numbers? Somebody, like, number or numbers, what do you think? 0? If n is 0? OK. Is that the only easy number? Are there any other easy numbers? 1. OK, right. So how about if n is less than 2? If n is 0 or n is 1, then I can just print it, right? C out n. That's pretty simple, because those numbers have the same binary representation as decimal. OK. But bigger numbers, that's tricky. So how do I do that? Well, it's all about recursion doing most of the work for me with magic, and me doing a little bit of the work, right? So what do you think is the unit of work here, the chunk of work that a particular call might handle? How much work does each call do potentially before passing on to another call? 1 digit, and to be really specific, maybe 1 binary digit. That's great. OK. So how about if it's a recursive case, I will print 1 digit, and the next call will do the rest, I hope. Which digit should I print? I think a lot of people sort of think of it as, let's sweep across the digits and print each one of them. Although sometimes you want to think about what's easier or harder to do in C++ or Java. Like plucking a digit off of a number, it's easier to do the last one than the first one. You understand? Because you can use div and mod to chop the last digit off of a number. Getting the top digit is like way up there. You'd have to do some exponent or something, or divide by some big thing. It's easier to grab the last digit. So what if the next call did all but 1 binary digit, b digit, or bit, you might say, and I will print the last one? OK? Now, how do you pluck a digit off of a number? Like if I said int last digit equals something, and then I said int rest of digits equals something, that would help me slice this number into the 2 pieces, right? Now be careful. If you're thinking about the number 43, I'm not talking about splitting up the 4 and the 3, am I? What am I really talking about? the 42 and the 1, kind of, right? Or, yeah, I mean, something like that, right? Like, I want the last digit of the binary part. I want the 10101 part, this part, to get printed by the recursion magic. And I want to do the last little one myself. Do you understand? So how do I pluck off? How do you get the last base 2 digit of a number? What do you think, sir?
You divide by the mod operator of 2?
Mod 2, right. The remainder from 2, if the number is odd, the last digit should be 1. If the number is even, the last digit should be 0. That sounds great. Last digit equals n mod 2. If you're thinking mod 10, again, that's if you're thinking decimal digits. So, OK, n mod 2. What is the rest of the digits? N minus last digit? OK, well, but what that'll do, I think, is it'll produce 101010, right? It'll be 42. So maybe that's what I want. But I think if I printed this and then printed this, that would be the right thing, you know? Yeah, n minus last digit would give me the 42 that's left over. But in a weird way, I want, like, what does it have? A 21, actually. Like, I want to print that, you know what I mean? And what is that number? Well, it's a 16 and a 4 and a 1. It's a 21. So, I mean, it's really more like n divided by 2. You know, like if you were going to take a base 10, the last digit would be mod 10, and the rest of the digits would be divide 10. You know what I mean? We're just doing that, but we're doing it in binary. We're doing it in base 2. So if we have the last digit and the rest of the digits, the recursion magic is supposed to print the rest of them. So what if I just said print binary the rest of the digits? And then for me, I just counted my last digit. What do you think? Let's try it. Let's compile it and run it. Wait, I don't know if my test cases are enabled up here. Let me go check. Up in main, print binary. Yeah, I think each one's supposed to have a line break between. So let me do that. OK, let's run it. What do we get? Oh, I've got some kind of even digits thing. Hang on, there's some other method here that we didn't write. So let me try again. Compile and run. OK, what do we got? Print binary of 2 equals 10. Print binary of 12. It looks like I'm getting the right stuff. I do have one that didn't come out right. Print binary of negative 500. It printed negative 500. That's not right. There was one of my favorite TV shows is called Futurama, and they have a lot of computer jokes and robot jokes, and they have this robot mafia, and they like shake down all the other robots. And Bender the robot says to them like, "Oh, what kind of crimes do you guys do?" And they're like, "Oh, you know, racketeering, extortion. We run numbers." And then the other guy leans in and he says, "Mostly ones and zeros." Anyway, this output that we got was mostly ones and zeros, but it should have been all ones and zeros. So print binary was supposed to handle negative 500. So I guess I didn't say that. What if you pass in a negative number? Well, I think if you do print binary of negative 43, I think it should probably print negative 101011. Is there a way to incorporate that here that won't destroy this code that we've written? Like, what's the cleanest way to absolute value? OK. Well, how about like if the n is less than 0, then I'm going to see out a minus sign. And then what? What if I just called myself with negative n, or absolute value of n? Right? You ever hear this one? Anyway, call yourself. Just call yourself with the absolute value of n. That will put you down here in whatever case is most appropriate. and then the code will resume from there. But we'll just print the little minus sign. So I think that'll take care of it. I want to point out one or two other things about this piece of code that might be interesting. Down here, where we say cout last digit, I want to point out that you could also have written print binary last digit. And it doesn't really make a difference, because print binary of last digit would be a digit that was less than 2, so it would jump back up and do this part. But I do think it's kind of interesting to think of it as like, I mean, here's the way I would describe it. The binary of 43 is the same as the binary of 21, which is 43 divided by 2, and then followed by, not literally plus, but followed by the binary of 1, which is 43 mod 2. That's like how I think of it. So there's the self-similarity in a nutshell. Printing the binary of 43 can be expressed as printing the binary of 21 and then printing the binary of 1. Like, that's the self-similarity. That's where the problem recurs within itself, you know? Song lyrics aside. Questions so far? Any questions about this one? Yeah.
I kind of don't understand the methodology of like why passing divide by 2 works.
Why passing divide by 2?
Yeah.
Well, if you think about the binary of 21, it's a 16 and then no 8s and then a 4 and then no 2s and then a 1. And then the binary of 1 is just a 1. And the overall binary of 43 is supposed to be that. So if you just printed both of those in that order, it would come out as 101011. If you keep following this, like, OK, what's the binary of 21? Well, that's the binary of 21 over 2, which is 10. And then the binary of 21 mod 2, which is 1. What's the binary of 10? Well, that's the binary of 5, and then the binary of 10 mod 2, which is 0. What's the binary of 5? It's the binary of 2, and then the binary of 1. What's the binary of 2? It's the binary of 1 followed by the binary of 0. So, like, what the hell, or where am I? But I think if I read this, I get 1, 0, 1, 0, 1. And so, I mean, that ends up being the digits I'm looking for. They print out in the order that I want them to print out, you know? I don't know if that makes sense. It's kind of hard. It's hard to draw this as text, right? I think let me show you another way. I tell you what, there's lots of ways you can come to feel more happy about recursion. One thing that helped me a lot when I was learning it, I discovered this trick. You can come up here to the top and just do cout I am in print binary parenthesis n parenthesis endl. And I mean, you don't have to say I am in. Maybe you could just put some spaces or something. You compile that and you run it, and it prints all the calls it makes. Put it at the very start, and you can just look at all the calls. So when I do print binary of 42, it does 21, which does 10, which does 5, which does 2, which does 1, which prints a 1 on the screen. And then we start coming back. This isn't perfect, because it would be nice if it were like nested, like the deeper I went in the calls, the more it was indented or something like that. It doesn't really do that. But this does help you see the order that things get called. So that might be a trick that you would want to use. What else? Any other questions so far about print binary? Well, let's look at another example together. Here, this comes from the slides for today, the new set of slides. So let's jump into there. OK, come on, wake up. There. And again, you know, recursion's hard. So if you want another reference, read the book. Chapter 7 and 8 are really good reference on this. Look at this one. Let's reverse a file. We read in a file, the contents of the file, it says 4 lines, roses are red, violets are blue, all my base belong to you. That's how I proposed to my fiance. She bought it, she fell for it. So Actually, I couldn't think of anything this romantic all by myself. I stole this from somewhere. Anyway, you want to print them out in the opposite order. Now, of course, we've been seeing ways to do things in the opposite order. You're probably thinking, put the lines in a vector, or put the lines in a stack, or something like that. Well, I'm going to say no data structures and no loops. So you basically don't get anything on this problem. But you could use recursion. Hooray. So how do you do this recursively? Well, recursion is good at flipping things around backwards sometimes, because you can use the stack of function calls almost the way that you would have used a data structure stack. But how? How do we actually do this? Well, how is this problem self-similar? What's the similarity? Another way of thinking about it is, could I write a function that would handle a small part of the task and then use magical recursion to do the rest of the task? What are the units of the task that I could chop it apart into? What portion could one call manage as opposed to leaving the rest for later? Do you have an idea, sir?
Yeah, you might be able to have your base case be if this is the last line, then print it. If it's not the last line, then call this function again on the next line or something.
OK, sure. So he says if I'm on the last line, like there's only one line left, I think you're thinking like an easy case, a case that's easy to reverse is a file with only one line, because I just read the line in from the stream and just print it. That's all I have to do. And a harder case would be multiple lines, so maybe that's where I do recursion. I think that's a good starting point. So what if I jump to Qt Creator, and I open this, and it's called reverse lines here. So this is the function we're supposed to write. And you said a single line file is the easy case. OK, so remember how we read files, right? You say string line, and then you call what function to read? Get line. It takes an input, and it takes the line, right? This function, how do we know how many lines there are in the file? We don't know how many are going to be coming ahead. But we can try to read lines and see if it was successful or not, right? And that's told by what is returned from the getLine function. So if the getLine returns true, that means there was a line, right? And else, there were no lines to read. So, So I guess, I like what you said. Like, maybe we will read one line for our call. And if there aren't any more lines, like that's the right track, I think. But there's no way to look ahead. You have to just do it. You have to just try to read it, and maybe it'll succeed, and maybe it won't succeed, right? So I just read a line, if there was one. But now that I've got it, I don't know what to do with it or how to know. Somewhere I need to call. If there's no lines, you know what I mean? I'm close, but I'm having a little trouble putting all the pieces together here. And I do think it's the right intuition of like a small file, a single line, that's easy, and lots of lines, big file, that's hard. That's probably where I'm going to use the recursion, right? OK, let me ask you this. I've got a thought experiment for you. This is another way some people kind of think about recursion. What if there was a function that I have already written for you? So I'm really, really nice like this, right? And it's called reverse lines cheat, lol. And it is a full implementation of reverse lines. I already wrote it before class. I've learned this before, so I think I got it right. And I will let you guys call it if you want to. You can use it. So we don't even need to do this problem. We can just call this thing. But there's just one condition. You are not allowed to call this function on the whole file. You have to do some work yourself. Get off your lazy butts. If you do a little bit of the work yourself, then I will allow you to call this function that I wrote for you guys that is a full working solution to the problem. Okay? So I think along the track of what you said, the unit of work that maybe we will choose to do as a class is this one line that we read. So if we read one line ourselves, we've got that line stored in this variable. We got it. That's not going to be the last line. You said if it's the last line, do this, but we just read the first one. So again, like if you're playing my game with this cheating function, Just forget recursion. We're not even using any recursion. We're not even going to do that. We just have to do some of the work ourselves. We just read the first line. What's the first line? It's roses are red, right? That's what we have. We stored that as our string. So now we're eventually going to want to print that line, right? But it prints at the end. It's the last thing that gets printed. So there's going to be some stuff to do here. And then we're going to print our line that we read, right? Before we print our line, what should we do? Do you have a suggestion? Yeah.
Can you store that line in like a temporary string and then call reverse lines on get line input line?
Well, this variable is like sort of a temporary variable that just our call has. So like if we make other calls, we will still hold on to this line as being our line. So if you want a temporary variable, I think line kind of is that, I think.
Can you just call reverse lines on the next one?
Right, so here, Marty has that great cheating function that he gave you that will reverse all the rest of the file. Now, of course, the way you think of it is if I already read roses are red, then the file stream is sitting here in front of the letter V. It's ready to read more. So if you gave that to Marty's cheating function, it would read in these 3 lines, and it would print them out backwards. It would print R belong to you, all my base, violets are blue. So it would do all of that work. That would be great. And then, we would just print the last line, and that would be so easy, right? So we could just call reverse lines cheat lol and pass it the stream, and it would reverse the rest. And then we would print the first line last, right? Isn't it great that Marty wrote that for us? That's so nice of him. Oh, by the way, what goes in the else? I try to read a line and nothing's there. I guess that means it was an empty file, right? Because we started trying to read the first part and nothing came out. So if you're reading an empty file and you're supposed to print it out, there's really nothing to print. There's nothing to do, right? So I think it's kind of an empty else. Else do nothing. So really, you could just delete this. I'll leave it here for now, but it could be just empty. It could just not have an else, I think. Sure isn't recursive, though, I guess. OK, well, let's run it. Oh, it's running the other one. So this one's called main2. I got to turn the other one off, the other file that we were writing last time. That's called main up here. I'll call you main goodbye. There, now you're not going to get run. OK, run. So reverse lines, poem.text. It prints roses are red, violets are blue, all my base, R belong to you. So it did print the lines in backwards order. That was great. But you might say, that doesn't really count, though, because I used this cheating function that Marty wrote. So I didn't do recursion at all. Do you want to see what this looks like? Wait, where is it? Oh, my God. I just call your function back. The power was within us all along. We did it. We reversed the file. Oh, my God. I don't think any of you saw that coming, did you? So just to be really, really clear what I'm saying here, like, you don't have to say reverse lines cheat lol. You just say reverse lines. Call yourself. Call your own function. And that's what recursion is in a weird way. It's like pretending that you're already done writing the function and that it already works. And so you can call it, even though that feels weird, and it's just going to do the right thing. You have to sort of, they call it a recursion leap of faith, where you call yourself knowing that you'll do the right thing, you know? You ever leave yourself a note and you're like, boy, I better really do this or else I'm going to be in trouble. Those taxes are due tonight. I don't know. You know, you write yourself a note and you have to be trusting yourself, you know? That's what happens when you write recursive code. And so I've kind of got where is it? Here's sort of a crawl of what this does. They call reverse lines. So now, at any given moment, I'm reading this file, and there's like a position of where it is at in the file, where it's reading from. So at the start, so I call reverse lines, and I say string line, get line. So that reads roses are red. That reads this. So I think this arrow goes down to there. And now it says, oh, I have to make another call. OK, fine. So I make a second call. get line. That reads violets are blue. So this second call, his copy of the variable stores violets are blue. Each of these calls stacking up has its own copy of that variable. That's important to understand. So now we make a third call. The pointer of where it is in the file goes down to there. Make a third call. We try to read a line. That grabs all my base. So that's what gets stored in there. And now we make a fourth call. That reads another line here, which reads R belong to you. So after that, the file is done, so there's no more to read. So that actually makes a fifth call, because it doesn't know that we're done yet. The fifth call tries to read a line, but it doesn't succeed. So this if fails, so it doesn't go any further. It just exits now. That goes back to the fourth call. At this point, keep in mind, no output has been printed yet. We've gone back from the fifth call, which failed, to the fourth call, which was holding a string of R belong to you. Now we've come back from doing this. So we do this, which prints R belong to you over there on the output. Now this call is done. So this exits back to here. This finishes, so he's holding line of all my base, which he prints. That comes out on the output. Now he's done, so he returns. Comes back to here. This guy's storing violets are blue, which he prints. Comes out on the output. He returns. You see what I'm saying? This is kind of how it goes. It prints out the lines in backwards order. So it is a little bit like the data structure of a stack. I stack up the function calls, and then as they return back, that's when the printing happens. The really important thing here is that this cout came after this reverse lines call. If I flip those two, it would just print the file in its original order, which is less interesting, I think. But the order of those two statements is crucial. So questions? Yeah.
Would it work if we didn't have the passing by reference?
Oh, great question. Does it have to be, so this is passed by reference, if stream ampersand. That ampersand's real important because it means they're all sharing the same read through the file. And so a lot of the recursive functions we write, the parameter that we pass to the next call is slightly different than the parameter that we were passed. So usually we pass n-1, or we chop a letter off the string, or something like that, right? This one, you still pass the same parameter of input, but what you've done is modified the internal state of input so that it's further toward the solution to the overall problem. So that if you didn't pass by reference, it wouldn't work, because actually you have to pass if streams by reference, or else you get syntax errors, because it doesn't know. It would want to make copies of them, and it doesn't know how to do that. So basically that would mess it up if we didn't pass by reference. It wouldn't work the way that we want.
But if we open some file outside, so like, yeah, inputs.open some text, and then we passed it without reference, it wouldn't know, like, it wouldn't work.
Well, but the way streams are passed is you don't have to say anything special. You just say if stream open and then reverse lines. So the syntax for them to pass it by reference is the same as the other syntax. So, I mean, but yeah, it is important that we're passing that by reference. This is necessary for it to work properly. What else? Any other questions about this one? Okay, well, let's do another one. So I think some data, by its nature, is self-similar. A really simple example to think about is the structure of the folders and the files on your computer, on your hard drive. If you wanted to crawl through that and print them all out, so what do you have in your hard drive? You have directories, you have folders. And those folders can contain files, right? But a folder can contain folders, and those folders can contain folders. So it's an arbitrarily nested structure, tree structure. It's self-similar, right? Because a folder can contain a folder. So if you were going to print a folder or crawl a folder, maybe that would involve crawling subfolders of the folder, or that kind of stuff, right? That's kind of where I'm coming from here. So, you know, unlike printing stars and binary numbers, which you could just do with a while loop or a for loop, this is an example of data that I think really lends itself to recursion. So I like this example a lot. Let's write a function that crawls a folder. OK, so what you should do here is you take the file name parameter, a string, and if that file is just some file on the hard drive, then just print out the file name. That's it. But if it's a directory, still print out its name, but then also print all the stuff inside of it. And if there's any folders in there, print what's inside of them. And if there's any folders in there, you print what's inside of them, arbitrarily deeply, OK? OK, how do we do it? Now, the picture here has indented output. And we will write that, but I want to come back to that. So let's not worry about indentation yet. Let's just print the same content first. So if I go back to this program, I want to write a function called crawl. It says string file name, string indent. Let's ignore string indent for now. Let's just do that later. OK, so remember what the description says. If it's just a normal file, print it. If it's a directory, print what's inside of it. Now, you might say, I don't know how to do things with files that are like that. Well, maybe it would help if I showed you this, right? These are some functions in our library that you can use that relate to files. So which of these functions do you think I should use? Like, what do I do to get started here?
Is file.
If it is a file, yeah, is file or is directory or whatever, right? So OK, if it is a file, OK, then what? I'm just supposed to print its name, right? Cout file name handle. OK, yeah, that was easy. And I don't see any recursion there. That's probably a base case, right? OK, else, it's probably a directory, recursive case. Now, if it's a directory, I said I want to print all the stuff inside the directory. And the way I could accomplish that is there's something called list directory, which takes the directory name and a vector by reference, and it'll fill the vector with all the files that are in that directory. So you say something like vector of strings files, and then you say list directory, that file name, into this files vector. So by reference, it will fill this with the file contents. Maybe you wonder, why doesn't this return the vector? Well, it has something to do with efficiency reasons. But anyway, that's how it works. So at the end of this call, this vector will contain all those files. So I could do a for each loop. For each string, this is like a sub file inside of the directory. For each of those sub files, I could see out the sub file. OK? So let's try that for a second. I don't know what directory it's going to run on. I don't remember the testing method here. What test crawl? Where's that? Oh, I'm just calling it. What am I calling it on? 106B lectures, lecture 08, recursion 2. OK, let's call it on my directory for today's class. And it prints. Oh, well, it's still reversing lines. Let me turn the reverse lines off. I don't want to read the Gettysburg Address backwards. OK, what is it printing? A pro and a lib and a res and a source. And is that right? Well, let's go look. So that's today's lecture. Hey, look, I printed all those things. Wow. But I'm not done, right? Because like inside of source, there's stuff, and I didn't print those. And inside of res, there's stuff, and I didn't print those. So, oops, I'm not finished yet. So let me jump back to crawl. So what should I do? There's something kind of important that is missing from this code. There's no fucking recursion here. If I say we're going to write a recursive function, it should call itself sometime, right? And no one's doing that yet. It's OK, we'll fix it. But I mean, I'm not upset. I'm just pointing out, like, if it's recursive, it should call itself. It doesn't need to call itself in the base case, but maybe here in the recursive case. Any ideas? Any thoughts? What do you think?
Crawl each subfile.
Instead of just printing each subfile, why don't we crawl the subfile? Yeah. Because if the subfile is just a file, which I think is kind of what we were assuming, it'll just print it, which is what our code did before. But if it's a directory, we'll start another loop for it and another loop for any of its kids and so on. So let's try that. Oh, list directory can't open this.pro. I need indent? Oh, wait, what? Crawl. Oh, I need to pass indent, pass the same indent. OK, whatever my indent was, I need to pass it. Wait, so why did it even compile without that? Wait, called by list directory, called by crawl. Line 87, called by line 88. Let me think. Why is that happening? Oh, I know why. So this has to do with absolute folders versus relative folders. I've given this lecture before, and I always make the same bug, which is like the name of the thing isn't just whatever.pro. It's like /home/step. I have to put all that stuff on there, or else it won't understand. So like, if the thing I'm looking at right now is a directory, then I want to list all the stuff in here. But like, really, I think I want to say it's like file name plus /plus. Do you understand? Like, because if I'm in the /foo folder, then I want to crawl /foo/subdirectory. I think that's kind of what's the issue here. I know this might be a little confusing, but let me try that. OK, a bunch of things are now appearing, and that's a good sign. So it's printing all, these are all like library files in my project for today, and it is printing all of the stuff. Hooray. So you might say, well, but in the slide, it didn't print these long paths. You know, I didn't really want to see all that. I just want to see the file names. You can do that. And the way you do that is instead of printing the file name, there's a method you can call here named, what is it? There are two functions, no jokes. Their names are getHead and getTail. And that will return just the directory or just the file name of one of these long strings. So like, I think I can say get the tail part of the file name. And that will print the when it actually prints it out, it won't print the directory on it. So that prints all these files with no directories. So now we're getting close. We just need the indentation part. So did you have a comment? Yeah.
Need to print the directory.
OK, that's a good point. If it's a directory, we still need to print its name like that. OK, that's fine too. Now, this leads into, if I'm going to print this in both cases, then maybe I should just move this up here. So, and then the base case becomes what? I don't need to do anything. But OK, what about indentation? The idea is that when you initially call crawl, you're going to pass in an empty string of indentation. But as you go deeper, you want to increase the indentation. And that will be like some number of spaces that you put at the start of the lines, something like that. So like, where's it calling crawl? Like up here in main, I would call crawl, and I'd pass in this directory here, and I would pass in nothing for the indentation, like empty string. But then when it made a subcall, maybe it would space it a little bit, and then the next call would space it, and I would use that as a prefix on all the lines that I print out. So where do I need to incorporate that into this code? Suggestions? Yes, sir.
Pass indent by reference and then increment it every time you go down.
OK. I don't like passing it by reference, I don't think, because what I think will happen there is they'll all share it, you know? And then if I increase it, I'll have to be really careful to decrease it when I come back. I actually think the easier thing to do is just to pass them a new indentation that's separate from mine. I think you could totally make it work with reference, but I don't think we need that here. I mean, where would I incorporate it into the code? Like you said here, if I'm going to make a subcrawl on a subdirectory or something, then instead of passing him the same indentation as me, maybe I'd pass him mine plus a couple of spaces or something, you know? But I'm not using it in the code, though. Where do I use it? Yeah? When I see out, first print the indent, which is just some leading spaces. So now, what do I see? I've got this file, and I've got this file, and then I've got this lib folder, and inside of that is this folder, and inside of that are these files. You see the nice, pretty indentation now? And then down here, I've got a private directory with these files, and I've got this directory. I've got a res directory with these. I've got a source directory with these. So I think it's working. OK? Pretty cool. Now, one thing I want to point out is, let me go back to the slides here. This indentation, sometimes when the person who's using this function, when they call it, they may not really feel like passing an indentation. You just say, crawl this folder. You'd figure out the indentation yourself. The indentation is almost like an implementation detail that we needed in order to get that part of the output to work. But the person who calls this might not really want to pass that. And so a way that you can do that is you could declare what's called an optional parameter. You say string indent equals empty string. And what that means is you can pass me an indentation, and if you do, I will use that. But if you do not pass me an indentation, if you just pass only one parameter and not a second parameter, then I will just default to being the empty string. And that works out really well here. And so here, when I declare crawl, I say string indent equals quote, quote. And now here in main, when I call crawl on line 30, I pass in the directory I want, or I could just pass no indentation. See, I just didn't put a second parameter right here, and it still just works. So that's just a little thing, but it's a nice feature of C++. Java doesn't have that. It's like one of those tiny things Java doesn't have. See, sometimes I say nice things about C++. But that'll be it for the quarter, though. OK, do I have time for this? I don't know if I have time for this. Yeah, I don't think I want to start something that I don't have time to go far enough into. So I think I will be a merciful tyrant today, and I will end class a couple of minutes early. You're welcome. Go to your sections, and good luck with your assignment. I'll see you Friday.